Alright, this is our AC powered LED light bulb project for methods. The required components for this project are 20 LEDs, 4 diodes, 1 electrolytic capacitor. You'll need a breadboard and some wires to implement some of the circuits, and then you'll need various kinds of resistors depending on the math you do. Okay, so the point of this project is to power LEDs by converting AC power to DC, but the first couple attempts we're just going to experiment with what happens if you use a DC source or an AC source in place of the DC source. So you can either use a waveform generator at 60 Hertz and about 13 or 14 volts, or you can use an actual transformer plugged into a wall outlet to get your AC source. If you set up this circuit on your breadboard, you'll have the AC current going, and then these are 2 current limiting resistors for your series of LEDs, just to make sure that you're not going to blow any of them up or anything. And when you power this circuit up, if you kind of move it around in front of you, and so the circuit kind of looks like that, and if you have it like this, you kind of move it around in front of you, you can see that the LEDs will flicker. And that's because all your LEDs are only on for half of the time because of the alternating current. Sometimes the current's going to be going in the negative direction, and LEDs are diodes, obviously, so when current goes back through them the wrong way, nothing happens, or they might blow up if it's too high of a current. And that's kind of the graph of what alternating current looks like, and that's the reason that they're only on half the time. So our second attempt is to take that same circuit and make one of the series of LEDs go in the opposite direction. So you'll still have your current limiting resistors, and what's happening here is currents going back and forth like this through the circuit. So at all times, at least half of your array of LEDs will be on, because the current will go this way and these will be on, and when it comes back this way, then this set of them will be on. But this setup is still inefficient because you're powering an array of LEDs and you're only getting half of them on at any given time. So the third design we have is the correct way to turn AC power into DC power. The resulting DC current will still vary a little bit with time, but instead of looking like this, it'll look something more like that. It'll be almost a constant voltage, constant current in one direction. And so what you do is you take your 4 diodes and you set them up like this, so you see that your alternating current source is connected to each side of this array, and you've got diodes going in this direction and then these are going in the same direction. So what's happening is as your current alternates, the positive will go this way and it'll only allow it to go back into the circuit through there, and when it alternates this way, it'll also go in the same direction. So you can constantly power your LEDs, and they will all be on the whole time. Also, this would be your load, and you're powering your load across the resistor in between the diodes, and the capacitor is added just to smooth out any waves, just so you can get even more constant current. And that's because if this simple setup, if one side tries to draw too much, it draws it from the capacitor instead of from the opposite side of the power supply, and vice versa. And so with that, this is called a bridge rectifying circuit, and you make it with simple diodes, and that's how you get DC current from an AC current supply. Okay, so now that I showed you the ideas behind the AC to DC circuit, here's the actual complete circuit. This is the array of diodes with the resistor and capacitor in the middle, and that would be your array of LEDs, and you just hook your current source or your alternating current source up to it. And you have LEDs that are on all the time. You kind of move it back and forth, you can tell they're not flickering.